Today we are going to be studying conjugate sets and rationalizing a denominator. So let's say we are given a set root of A plus root of B, and you are asked to find its conjugate set. It's simply root of A minus root of B. So for example, if you are given root of 5 plus root of 4 plus root of 5. Sorry. Let's say root of 2 plus root of 5. And you have to find its conjugate set. It's going to be root of 2 minus root of 5. Or let's say root of 3 plus 2. Find its conjugate set is root of 3 minus 2. Yeah, so that's just it for conjugate sets. And another thing we should note is that when you are multiplying two conjugate sets, your answer is always a rational number. So for example, let's pick root of 2 plus root of 5. So let's say root of 2 plus root of 5 multiplied by its conjugate set. So we have root of 2 minus root of 5. So let's see if we get a rational number. So like we learned from our previous video, pick the first member, multiply it with the second term. So root of 2 multiplying root of 2 minus root of 5 plus root of 5 multiplying root of 2 minus root of 5. So root of 2 multiplying root of 2 gives 2 minus root of 2 times root of 5 gives root of 10 plus root of 5 times root of 2 gives root of 10 minus, because wherever positive and negative coincide, the negative dominates. So root of 5 times root of 5 gives 5. So here we have minus 10 plus 10. This is just like saying minus 1 plus 1, which gives 0. Why does it give 0? It's just like switching this here and bringing this here. So 1, so when this comes here, minus 1, 0. So minus root of 10 plus root of 10 gives 0. So we are left with 2 minus 5, which gives minus 3. And yeah, this is a rational number, even though it's negative, because all integers are rational numbers. So let me give you another question and try and solve. So let's say you are given root of 7 plus 2. You are supposed to find the product when you multiply it with this conjugate set. So let's try this out. Okay, so what's this conjugate set? Is going to be root of 7 minus 2. So as always, root of 7 multiplying root of 7 minus 2 plus 2 root of 7 minus 2. Root of 7 times root of 7 giving 7. Root of 7 times minus 2 gives minus 2 root of 7. Let's not forget to apply our rules. We shouldn't forget the rules. Plus 2 times root of 7, 2 root of 7, and 2 times 2 times minus 2, minus 4. So in this case we have minus 2 root of 7 plus 2 root of 7, which also gives 0. So we are left with 7 minus 4, which gives 3. So it's clear and it's evident that the product of two conjugate sets gives a rational number. Yeah. So let's move on to rationalizing denominators. But let's try and take notice of something. If you remember, there's this rule, a difference of two squares, which says that a squared minus b squared is equal to a plus b a minus b. Now, from this question, it seems, no, not that it seems, it's evident that a root of 7 represents a and 2 represents b. So, meaning wherever we see a, we place root of 7, wherever we see b, we place 2. So this is just another method. So let's see, root of 7 squared minus 2 squared. So root of 7 squared gives 7. Let's not forget the root. And 2 squared gives 4. 7 4 gives 3. So yeah, it gives the same answer. Let's try it with our previous question. Our other question was root of 2 plus root of 5, root of 2 minus root of 5. So let's place it inside this formula. So root of 2 squared minus root of 5 squared. Root of 2 squared gives 2, root of 5 squared gives 5, which gives minus 3. Which was the same answer as what we got when we multiplied root of 2. So yeah, so you can decide to use these two formulas. It's either you use the difference of 2 squares for this one, but for clarity's sake, I would suggest that you use this method. Yeah. So let's skip right to rationalizing a denominator. Well, the importance of rationalizing a denominator is to change the denominator or a fraction in a set form to have a rational number as its denominator. So for example, this is considered as a fraction in a set form because the denominator has a set. So in order to rationalize, we just have to multiply the numerator and the denominator by the conjugate set in order to get a rational number as the denominator. And when you have single sets like these, all you have to do is just multiply by the same thing. Since there's no additional or negative sign attached, we just multiply by root of 2, root of 2. So 1 times root of 2 gives root of 2, and root of 2 times root of 2 gives 2. So as we can see, we have a rational number being our denominator, which is 2. Or let's say 2 over root of 3. We want to rationalize it, we just multiply by root of 3, root of 3. So remember, you multiply the numerator and the denominator by the conjugate set. So 2 times root of 3 gives 2 root of 3. Root of 3 times root of 3 gives 3. So let's move to something much more complex. So let's say we are given 3 root of 2 all over 5 minus root of 2. We have to rationalize this. How do we do it? We multiply the top, the numerator and the bottom and the denominator by the conjugate set. So 5 minus root of 2, its conjugate set is going to be 5 plus root of 2. So remember, it multiplies the numerator and the denominator. So we're going to do this. 5 plus root of 2. 5 minus root of 2. 5 plus root of 2. So 3 root of 2 times 5 gives 15 root of 2. And 3 root of 2 times root of 2. So here is just 3, then into bracket root of 2 times root of 2 giving 2. Now, when it comes to rationalizing the denominator, when it gets to this part, I usually like to apply the difference of 2 squares. So I just pick 5 squared minus root of 2 squared. So this gives 15 root of 2 plus 6 all over 5 squared gives 25 root of 2 squared gives 2, which gives us 15 root of 2 plus 6 all over 25 minus 2, giving 23. That's our final answer. And as you can see, we ended with a rational number being our denominator. So maybe when you get to this side, you can decide to do it like the first method I taught you. So I just want us to take note of the second method. It is known as the difference of two squares. As you can see, this is the first square, this is the second square. So the difference of two squares. When you have something like this is how you represent it. And when it's given to you like this, you can turn it to this form. So let's pick another question and try to solve. So let's say we have, let me see, 1 over 4 minus root of 5. You have to rationalize this. So pause the video and try and solve this question. So this is going to be 1, what's the conjugate said to be 4 plus root of 5, both top and bottom. So 1 times 4 plus root of 5, and as we all know, 1 times any number gives the number itself. So this is going to give 4 plus root of 5. And 4 minus root of 5, 4 plus root of 5. So to make this quick, I'll just apply the difference of two squares. So 4 squared minus root of 5 squared. 4 plus root of 5. 4 squared gives 16, 5. Root of 5 squared gives 5. Giving us 4 plus root of 5 all over 11. That's our final answer. So let's solve one more question. 2 plus root of 3 all over root of 3 minus 1. So pause it and try and solve it. So now this is going to be times root of 3 conjugated plus 1. Plus root of 3 plus 1, root of 3 minus 1, root of 3 plus 1. We pick each member used to multiply the second term. Plus root of 3 plus 1. So applying difference of two squares. Root of 3 whole squared minus 1 whole squared. So that's root of 3, 2 root of 3, 2 times 1, 2 root of 3 times root of 3 gives 3, and root of 3 times 1 gives root of 3. Root of 3 squared gives 3, 1 squared gives 1. So if we were to group like terms, 2 root of 3 plus root of 3 gives 3 root of 3, and 2 plus 3 gives 5 all over 2. And as you can see, all our answers are ending with a rational number being the denominator. So let's keep this in mind. If you are not getting a rational number as your denominator, then there's something wrong with your solution. So always keep in mind, when you're rationalizing a denominator, always make sure it ends with a rational number. That's why it's called rationalizing. So yeah, thank you for watching this video. I hope you learned a lot. Don't forget to hit the notification bell and always subscribe to get more updates on my recent content. Thank you very much.